All right. Hello. We are here again. This is for Newton's cooling equation, which is the third question in your final exam. So let me share my screen. Okay. Here you go. So the question is this is similar to what I had given in the exam. An object is initially at a temperature of 100 degrees Celsius, initial temperature, and it's placed in a room where the ambient temperature is 20 degrees Celsius. So, example, I have a water bottle filled with water and I put it in the freezer. And when I took it, I put it in a room that is 100 degrees Celsius, for example. Um, and is placed in, of course, it will melt, correct? Or we can also have a situation where you got a cup of very hot water. It was boiling, so it was boiling hot. So the initial temperature was 100 degrees Celsius as well. And then you put it in a room in an ambient temperature in a room where it's 20 degrees Celsius or centigrade. And that 20 degrees Celsius will be a constant temperature in that room. So, how long can that boiling hot water be be cooled down? Or if it is ice, how long will it take to melt at a certain time? Okay. So there is a relationship between the rate of change of its temperature with respect to time. It says here they are directly proportional to the difference between object's temperature and the room temperature. So the first question in here is write down the differential equation that models the rate of change temperature T of the object with respect to time t using the Newton's law of cooling. Now, it says a while ago that the rate of change of temperature is directly proportional to the difference of the initial temperature and the ambient temperature. Now, there is a proportionality symbol here. If you're going to change that, then delta T will be equal to a K, T minus TA. Now, because this is a Newton's law of cooling, then it means that from a high temperature to a negative temperature will be done in here. So you expect a negative K. All right. It can be from boiling hot to a normal temperature, room temperature, or up to freezing point, or even a lower temperature. So, what is the equation? If we're going to change the delta T, that will be d big T with respect to time. Okay, equal to minus K because it goes down times the difference of the two temperatures. So this is the dE of the relationship between the two temperatures. Number two, let's solve the different let's solve the differential equation. So this was the given differential equations, yeah? We will arrange the variables. So the dt will be up, and then here, this one will go down here over t minus ta, all t's together, equal to minus k will still be here on the right side, doesn't change, and your dt goes down here. k dt. That's why we have this equation, arrangement of the variables. Now, the TA here is constant, and the T is the one that will be differentiated. We have a derivative of ln u, which is 1 over u du over dx. Okay? So if this denominator has got a derivative which is d over dx, and this goes to the numerator, then the integral of that is ln u. That is what has happened here. TA is constant, and the derivative of t is dt, hence the integral of dt over t minus ta is ln t minus a, because that is your u. So ln of t minus ta, okay, equal to the integral of minus k dt, and the integral of dt is t plus a constant. So the explanation for this one here, to remove the ln here, then you have to raise both kt and c as a power to remove ln. So t minus ta will be equal to e raised to minus kt plus c, or this will be minus kt ln e. Okay, and then plus c. But that is, what is this? 1, correct? Okay. Now, we can also do it in another way. We can do it like e to the negative kt times, because this is a plus, e to the c. But e to the c will be c ln e equal to 1. So we can multiply the c and e to the kt, gives us a product, which is c e to the kt. Okay. Therefore, the t of t will be equal to ce to the kt plus, we move this one to the other side, giving you t equal to ce raised to minus kt plus ta. Right. Now, in number 3, if after 5 minutes the object's temperature has decreased to 60 degrees Celsius, write or determine the specific solution for the temperature of T of the object using the formula that was derived. Okay, find the specific solution. For initial conditions, when T is 0, then the initial which was in the problem statement, is 100 degrees Celsius. So when T is 0, T sub O, or 0, this was T equal to T sub T, CE to the negative KT plus TA. All right. So when T is 0, that will be T of 0 equal to CE minus K times 0 plus T plus 20. It's very slow in erasing it. Okay, there you go. Now, but what is T of 0? It's 100. So that's what is placed in there. And because this is e to the negative k times 0 will be e to the 0. E to the 0 is 1. So you only have c left. Plus 20. So c will be 100 minus 20. That is 80. Now, because we have found c, then the equation, which was t of t is equal to 80 e. It wasn't 80 at first, correct? It was c e to the negative kt plus ta. So t's of t will be equal to, we found c to be 80, so 80 e to the negative kt plus 20, which is this. Now calculating the time for the object to cool to 30 degrees Celsius, then T will be equal to 30 degrees Celsius. You substitute it. There you go. Look, this one will be 30, and then 80 e to the negative kt plus 20, right? So we will have a variable e raised to negative kt here, which is equal to 10 over 80, or simply 1 over 8. Taking the natural logarithm of both sides. So why do we have to do that? Because of the e here. So if we have e to the negative kt, the natural logarithm will be minus kt ln e, but that is equal to 1. And the number or the fraction will be with a natural logarithm before it ln and close it. So looking for or calculating for t, you divide both sides by negative k, then you get 1 over negative k. Then that negative k here and that cancels out, and here it becomes a multiplier. So t here is equal to negative 1 over k ln of 1 over 8. And we substitute that in our formula. Now we need to find the value of k to calculate the time. Okay, here. Okay, let me just okay, let's copy that and put it here. Sometimes hey, anyway, let's just put it there. Okay, so it's not working that smart anymore, or it's not working that fast. Where are we? Here. All right. So T of 5 is equal to 60 degrees. This one, put it there. We are now using our T of T equal to 80 e negative 5k plus 20, which is the TA. Okay. Now T of 5 is equal to 60. 60 is equal to 20 plus 80 e to the negative 5k. All right. So 60 minus 20 is 40. So 40 is equal to 80 e to the negative 5k. And you have to divide both sides by 80, so you get 1/2 is equal to e to the negative 5k. Again, you have to use natural logarithm. Negative 5k ln e is equal to ln 1/2. So that becomes 1. To find for k, you have negative 1/5 ln of 1/2. That's why we have this one. Okay. Now substitute the value of k into the equation for t. Where's the equation for t? The equation for t is here. Correct? There. So t minus 1k, 1 over k ln 1 over x. Substitute our k. K is negative 1/5 ln 1/2. So k is negative 1/5 ln 1/2 ln 1 over 8. So let's simplify the expressions. So t will be equal to because this was 1/5, so you just switch it. 5 goes there, and then negative and negative becomes positive. Okay, right? If you can see this one, negative, let me just zoom it so you can see it. All right. Here, the 5 here, because it's all multiplication, when you switch place, this goes up, and the negative and negative becomes positive. So we have positive 5 ln 1/2 and ln 1/8. Okay, and then this will be 1/8 can be 8 to the negative 1 because we move this one up. Okay, and why is this ln 1/2? It can be 1/2 okay, so 5 ln 2 times 8. Here, let me just explain this one. 8 to the negative 1/2, or ln 2 raised to negative 3. 2 times 2, negative 2 times negative 2 is negative positive 4, times minus 2 will be equal to negative 8. Correct? All right. So if that will be multiplied by 8 to the negative 1, or 1 over 8. So let's see. If we put this one here, that will be negative 3 ln 2. Okay, which is this one. It's becoming slow. It's this one. Okay. Then 5 over ln 2. If you're going to simplify this one, then you get negative 15t if you use your calculator. All right. Okay, then. So, what is this t equal to minus 15? Therefore, after solving for t using the given values, we get t is equal to negative 15 minutes. This indicates that the object would have cooled to 30 degrees Celsius after 15 minutes. Okay. How did we know it's 30 degrees after 15 minutes? Okay, let's see. Okay, it's becoming slow. Okay, here you go. So, how do we know that it's 30 minutes? Given is t of t is equal to 30 degrees Celsius. We have to get for the time. And the value we got was t is equal to 15 degrees, no, 15 minutes, I should say. Right. So t that was taken here was 15 minutes. 15 minutes. When 15 minutes to reach 30 degrees Celsius. It's given in number 4. Okay. What time does it take, or how many minutes does it take for the object to cool to 30 degrees? So it needs 15 minutes to cool it. Okay. So I hope I have shared what is important for you to understand in the exam. Here. There you go. Hence this explanation. Okay, then, so we are not going to make it longer. I hope you understood it, and goodbye to everybody. Thanks for watching, and please just type in any confusion, anything that you want to know down below. Bye for now.